Dear students, detailed civil engineering courses like Manual Building Design, STAT Pro, ETABS, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Strava online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Hello everyone, welcome back to my YouTube channel Civil Engineering by Shravan. If you are not yet subscribed to my channel, please click on subscribe button and click on bell icon for more interesting updates on civil engineering. So in this video, I will explain you complete designing of the building structural model, which is of G+5 model with the help of composite columns by using SAP2000 software. So I was already explained the video related to the ETABS software, which comes under the composite column building. But in this video, I will cover you the basic concepts related to composite column building. What do you mean by composite column building and how it will be helpful for decreasing of the seismic loading condition system. Then after that, I will show you the modeling process and I will show you the analysis process of the building structural model under considerations of the load cases, and how to design that particular building by using SAP2000 software. So let's start our video. So here I'm selecting my PDF. This is the composite column building general introduction document, which is consisting of 4 pages. So basically you can see here, composite is nothing but the combination of 2 or more materials. So here in this case, we are combining the materials related to the concrete as well as the steel. So rebar is also secondary material as the composite column building in this RCC structure. In addition to the rebar material, we are adding the angle sections or I sections or T sections, any other sections in the composite column building structural model. So based on the resistance of the structure, we can reduce the seismic loading condition system as per IS 1893 code provision standard system. If you consider the RCC structure model, then the resistance of the structure will be less because of the presence of the less steel in the particular column structure. So in order to increase the resistance of the structure to overcome the seismic loading condition, we are proposing the composite column building structural model here. Okay, so now we can see these are the PDF. I will upload this PDF in Civil Engineering by Shravan application. You can see the complete PDF in the free PDF section in the Civil Engineering by Shravan. You can download the PDF and you can take the print for the reference. Okay, so if you are not yet downloaded my application, please download the application. The download link is available in the below description of this video. The complete lectures and complete courses of STAT Pro, ETABS, SAP is available in the Civil Engineering by Shravan application under the offer now. Okay, so these are the some uses of the composite column and composite column constructions sections here. Now we can see this is the high-rise building which is exist with the help of the composite column building. So if any kind of the seismic loading occur for this high-rise building, then it will resist automatically because of the presence of the resistance from the ground level. So this is the major advantage for the composite column building. So let's start our modeling of the building by using SAP2000 software. So here I am selecting my SAP2000 software. So now we can see here the SAP software was open here like this. So in this example, I am taking regular building. So which is consisting of approximately 15 meter across 15 meter. Each bay will be consisting of 3 meter in X direction as well as the Y direction for the building as per the composite column section. Go to the file option, click on new model option here. So here we had to select the model according to the 3D frame model. So here initially we need to select the initialization model and default material units as per the Indian standard and kilonewton meter center section. So click on the 3D frame option here. So number of stories you have to enter. As per my consideration, just I am taking G+5, which is makes as 6 stories and story height is 3 meter here. Number of bays in X direction I am taking 5 number. Bay width is 3 meter. Again I am selecting 5 numbers in bay width is 3 meter. So select the custom grid spacing option if you want to edit the grids. Otherwise keep it as constant. So now we have to select the beams and columns dimensions for this particular building. So for that we have to click on the place mark here. Initially we need to add the new property. Click on add property. Firstly I am selecting the property which is of concrete section. So which is related to the beam section. Just I am taking beam. Just I am writing here as beam. sorry, just I am writing here as beam. So select the depth of the beam. Here I am taking depth of the beam is 0.86 and width of the beam just I am taking here as 0.3, and select the grade of the concrete. As per the default section I am taking M30 grade. If you want to take the high grade of the concrete like M40, M25, you can consider according to your assumption. So click on the concrete reinforcement option here and select the HYSD bar rebar materials option. So select here as place mark in order to add the new rebar material. Click on add a new material option here. So here you can see it will be consisting of region, material, standard, grade. You can assume the region as per the Indian code. We are considering material type will be of rebar material. It is not steel material. Why? Because we are using the steel as the rebar in the RCC sections. So I am selecting here. Standard is Indian. Select as per the IS 500, HYSD 500 here. Click on OK option. Click on OK. Now we will change the longitudinal bar confinement as HYSD 500 here. And you can consider the design type here. It is consisting of two types like beam and column. So instead of the column, we will select the moment only, which is of M3 design only. So now we have to select the top cover as well as the bottom cover. Just I am selecting here as 40 mm cover, which is exist at the top section as well as the bottom section for this beam. So click on OK option. Now after this, we have to click on OK. Again in the same process, we had to add a new property which is related to composite column section. Now we have to add the property. Click on add property. So here we have to select that section designer from other section in order to add the composite column. So instead of the concrete, we have to select other here and section designer. Firstly, we will add one material which is related to some grade of the concrete, Fe 250 or 345 grade, depends upon a consideration. Most of the people will consider Fe 250 grade only. So that's why initially I will add material, add new material which is related to Indian steel as per Fe 250 grade. Click on OK option. Click on OK. Again we will select Fe 250 grade from this particular section. So this is the base material. Instead of base material, you can select M30 grade concrete also as the composite column building. Okay, so I am selecting composite with the base material as M30. Click on section designer option. So firstly we will add the column section. So inside the column section we will add the composite column member section. Go to draw option initially. So draw solid shapes. Click on the rectangular property. Just I am adding here. So now we can see we are added the property here like this. So firstly we will select this particular rectangular property. Right click on that particular option. So we will edit the dimensions for the section. So here you can see it will be consisting of M30 grade with the major axis dimensions, height as well as the core dimensions. So here I am entering the height of the particular column is 0.46 and 0.46 is the dimensions for this particular column. Just I am entering here as the width as well as the depth of the column. Click on OK. After this we have to add the steel member inside this. So firstly we will add the rebar, then after that we will add the steel member. So for that just I am selecting bar size here, right click on that option and we have to select the bar size. Just I am selecting 12D as the dimensions, and bar spacing you can consider as per your consideration. Bar area you can take as per the assumption which you are considered. Click on OK option. Okay, now we have to edit the dimensions for this particular bar section. Initially I am selecting this reinforcing bar which is consisting of approximately 0.3 cross 0.3 dimensions here for this particular member. Just I am selecting, click on OK option. Again we will click on OK option so that the reinforcement bar will be applied here like this. If you wanted to edit the reinforcing bar dimensions again, you can consider this and you can right click on this option. You can increase the dimensions as per your assumption. Just I am taking 0.4 cross 0.4 is my dimensions for this particular bar. Click on OK. Now we will draw the sections. Go to draw option, draw structural shape, I section flange. Just I am selecting the center point here. So now we can see it will draw the I section here. We will change the dimensions of the I section as the steel member section for this member. So right click on that option, select that particular property and right click on that particular I section. I am taking this as 0.3 height and 0.3 width and 0.03 and this is also 0.03, 0.3 3 0.03 here. Click on OK option here. Before that we have to edit the what we call material property for this particular section also. So for that, just I am selecting dynamic zoom option for this member. We have to select this particular eye section here, and we will change the section material as FE 250 grade here. So instead of 3 we will add 250 grade. Click on OK option. Again we will cancel this option. Click on yes option, save option here. So after this, composite column will be uploaded here. Click on OK option. Now we will click on OK. Now here we select the beam instead of the column. Click on OK option. Now you can see it will show your complete structure here like this. So you can assume the left hand side as the 2D view as well as the right hand side as the 3D view according to your considerations of the model. Now we will add the slab section for this building. Go to define option for that, section property, area section. Click on add option. Slab, just I am selecting here 150 mm is the thickness. So I am selecting 0.15 and this is also 0.15 is the thickness for the slab. M30 grade with M30 grade. Click on OK. Again click on OK. So draw the slab section here. So just I am selecting this quick draw areas option. So just I am selecting the slab section. Just I am drawing this particular slab section at this location so that it will draw the slab section at this portion. So now we will select the slab section and we will copy this slab section to the remaining story. For that, go to select option, select properties, area section. Just I am selecting here as slab. Select here 1, 2, 3, 4, 5 is there. Go to edit option. So we will go to the replicate option in the direction which is related to, this is x direction, this is y direction, and z direction we have to copy with the 3 meter each. 1, 2, 3, 4, 5 stages. So 5 stages just I am applying here. Click on apply option so that it will copy the slab sections here for the building structural model here like this. Now after this we have to click on the right mark option here in order to see the model in correct view option. Go to fill objects, apply to all windows, click on apply option here. Now after this we have to click on OK option here so that it will completely show your structural model which is related to the building structural model with the slab section here like this according to your assumed data. Now after this we have to define the load cases which is related to both the gravity loading condition systems as well as the lateral loading condition systems for the building. For that, go to define option here, go to load cases option here. So it is consisting of 2 load cases is available which is related to linear models. So initially we will go to the load patterns option. So it is consisting of dead load here only 1 load cases. So just I am adding live load case. Just I am selecting here live add option. Now I am selecting earthquake load which is related to x direction condition system. Just I am assuming. Again I am selecting here as seismic loading condition from this particular option quick. Select as per the IS code provision standard system 1893 2016 code. Again in the same process we have to add the code as per the y direction condition system. Click on add option. Again I am selecting wind load which is exist in x direction condition which is related to the wind. We will select as per the IS 875 2015. Again I am selecting y direction condition system. Now we will select the earthquake load in x direction. We will modify the property inside this particular load cases. Go to modify load pattern option here, select here and select your direction. So here earthquake load will be applied in x direction condition system. That's why I am selecting here as global x direction. And you can consider the per code value. You can consider the per code value according to your assumed data. So here I am assuming the per code value will be of 0.36 value according to my assumed zone 5 seismic condition systems. Soil type will be of 2. Just I am assuming here. Click on OK option. Select earthquake load in y direction condition system. Modify lateral load option. Again select the direction will be of y direction condition system. Click on OK option. Again I am selecting here wind load which is exist in x direction condition system. Modify lateral load. So you can consider the wind speed according to your assumed data. Just I am selecting here as 44. And terrain category will be assumed as per your consideration. Just I am taking as 3 as the terrain. So you can consider wind direction angle and wind coefficient leeward values according to your assumed data. So click on OK option. Again I'm selecting wind y, click on OK. Again I'm selecting this is also 44, terrain 3. You can assume your data as per your consideration. So x direction is always perpendicular to y direction condition system. That's why I'm taking wind direction angle is 90 degrees here. Click on OK. Again click on OK option. Now after defining the load cases, we had to apply the load cases for the building. For that, initially I am selecting all the building. For applying the dead load condition system, under the dead load we had to apply the self weight initially. Go to assign joint loads option, select the forces. So select the add to existing loading condition here. Select global forces 1 1 1 1 1 1 1 here. So click on apply option so that it will apply the self weight condition system for the building. After this we will apply the load case which is related to wall loading condition system for the building. For that we have to select the beams. Go to select option, select property, frame section. Just I am selecting the beams here. So basically loads which is consisting of the wall load is external wall loading condition, internal wall loading condition as well as the parapet wall loading condition system. So just I am taking 0.23 is the external wall loading condition system. We have to multiply this respected load with the height of the structure 3 meter and we have to multiply this respected load with the 20 so that it will get the values. 13.8 kilonewton per meter is the external wall load. In the same process 0.125 is the thickness of the wall, and if I multiply this with 3 then it will be get the value of 7.5 is the internal wall loading condition system. Along with that it will be consisting of parapet wall load also. 0.125 is the thickness of the parapet wall load multiplied by 1.2 meter height multiplied by 20 so that it will get the parapet wall load as 3. So 3 plus 7.5 plus 13.8 which will get as 24.3 kilonewton per meter intensity. Go to assign frame line load, distributed condition, add to existing loading condition. We will enter the uniform load here 24.3 kilonewton per meter intensity. Click on apply option so that it will apply the 24.3 kilonewton per meter intensity in gravity direction condition for this building. After this we will apply the slab loading condition system which is related to the marbles and tiles. 0.1 is the thickness of the marble, just I am assuming here. If I multiply this respected value with 20 so that it will get as 2 kilonewton per meter square is the area load which is applied for this particular slab. Go to select option, select properties. Just I am selecting here as area section. Just I am selecting slab 150. Click on close option. Go to assign. Just I am selecting here as area load, uniform shell. Select dead load. So you can apply as 2 kilonewton per meter square. Add to existing loading condition, click on apply so that it will apply the dead load for the particular marbles and tiles. Again in the same process we will apply the live load. For that we have to select all the slabs by using previous section option here. Go to assign option, area load option, uniform shell option here, and I am assuming here as 3 kilonewton per meter square as the live load for this particular model. Add to existing, click on apply, click on OK option so that it will apply the load for the particular structure. Now after this we will apply the load combination. Go to define options, load combinations option, add default design combination according to concrete frame design. Click on OK option, click on OK option so that it will apply the load combination for the structure. In the same process we will apply the support conditions at the base. Just I am selecting the base here for this model like this. Just I am selecting base here for this model here like this. Just I am selecting all the node points at the base. Go to assign joint, select here as restraints option, fixed support conditions, click on apply, click on OK option so that it will apply the fixed support conditions at the base for the model. Now after this we have to do the analysis process for this structure. Go to analyze option, set analysis option here, click on OK. Again go to analyze, set load cases to run option, or else directly click on the run now option. So click on the run now option so that it will do the analysis process for this building with the considerations of the load. Just I am saving as class. Let us take as the class as the folder. Just I am saving here. G+5 just I am assuming here. So that it will do the analysis process with the considerations of the all the load cases as well as the load combination. Then after that I will show you the deflection diagram, shear diagram as well as the bending diagram for this model as the analysis results. Then we will see the designing process of composite column building by using SAP2000 software. So now I am selecting 3D model here. Now we can see this is the deflection diagram according to your dead loading condition. If you wanted to see the deflection diagram according to your assumed data, you can click on show deform shape as per your considered load case. Just I am selecting earthquake load in X direction, click on apply. If I apply here, then the building will be deflecting in this direction. Again in the same process, if I select in Y direction, then it will show you deflection diagram here like this according to our assumed data. Okay. So in the same process, we will do the shear force diagram. So go to forces. Sorry. Just I'm going to the display option. Force, frame span, force. Select shear to option. Click on apply so that it will apply the shear force diagram here like this. Bending moment 3. Click on apply so that it will show you the complete bending moment diagram for this model here like this. Now we are done with the complete analysis process. We will do the designing process for the building. For that, go to design option here. Select the concrete frame design. Select view revised preferences. So here we are taking the base material for the particular composite column as RCC section only. That's why we have to consider the designing also as per the RCC section only. So select this as IS code. Just I am selecting 456-2000 and keep every parameter as constant. Click on OK. Go to design option, concrete frame design. So select the start designing check option so that it will start designing of the member according to your IS 456-2000 code provision standard system. Now we can see here it was done with complete designing of the building structural model. You can pick any one of the beam or column according to your considerations. Right click on that particular option. You can go to the summary so that it will show you the complete summary of the design result which is applied for this particular building structural model. In the same process, you can see the results as per your column considerations also. So here I am selecting this particular member. Go to summary option so that it will show you the complete designing results of the building structural model as per assumption. And again in the same process, if you wanted to do the designing as per the composite member, you can do the composite member design also. So here I am doing only the as per the RCC section only. You can consider the composite column according to your assumption. So thank you for watching this video. If you have any queries about this video, please try to text me your questions in the below comment box so that I will give you that replies for that particular questions. See you in the next video.